Hello, everybody. It is Mr. Trochet with another lesson for 9.2.1 and what is it? It's CC Core Connections 2, which is the seventh grade book. Sorry about that. So 9.21 surface area, and does that affect the volume? And actually vice versa. Does volume affect the surface area and all those things? So there's a few things that we need to talk about. I'm going to go through this very quickly, and not because I don't want to go in depth, but just because I think that we can speed things up a little bit more. So the thing about this is that we have volume, and volume is what is inside. Volume is what is inside your box. So the volume is how much, maybe the volume is the area inside. That maybe it's the weight, or the amount inside. I should say weight, or the amount of inside, and volume can be many things too. It can be liquid, it can be solids. So the volume is the space inside that can be filled up. Then we have surface area. And surface area is basically going to be what is around the box. So that's going to be, so volume is inside the box, surface area is around the box. So if I were to just take this water bottle, for example, the surface area is the black on the outside here. It's also the black down here. Now, you can't really count the surface area on top because it's open, but the surface area is everything on the outside that's covering it. Volume is everything inside. And so here we have the liquid, and I just poured water on my keyboard. No, I just one drop. But that is the volume. The volume is liquid volume inside, surface area is around. So they're going to be talking about a few things. So here we have Morning Math Crunch cereal. That is 2 inches deep by 4 inches wide by 8 inches tall. So let's go ahead and talk about this right here. We have 8 inches tall, 4 inches wide, and 2 inches deep. And that can be length in a situation. So let's make this height. Let's make this width, and let's make that length. And so we're just going to put variables for that and measure them. So this is a rectangular prism. We know that there are 4 sides to a square, for example. But since this is a cube in a way, or a prism, rectangular prism, there's 6. All right. So, and the reason it's just like a die. So we have a die. For example, you only see 1, 2, 3 sides here, but that doesn't mean that there isn't another 4th side on the back side, a 5th side right in the back, and then a 6th side underneath. All right. So there's going to be 6 spots, 6 faces. That's the thing. It's called faces. So faces are basically all the things around. And they also call them bases too. So faces are the sides of the box. All right. And so, and that's rectangular to the bases. So here are the faces that are around the box, right? And then the bases are on the top and on the bottom. So base, and then the face. Here's the face and the base. I don't know why I did that, but maybe that'll help you. All right, moving on to our stuff right here. We have pen. Describe the box as clearly you can, include the information. What shapes do you see when you look at the faces of the box? I see a rectangle, 8 by 4. I see 24 inches squared. What lengths and other measurements can you describe? So the height is 8. The length or width is 4, and that's it. There's another face, and that this is going to be 2 in length, and it's going to be 8 in height. So this is the front side. That's the front side, and then this pink side is going to be this side. So just so you can match that up. Sketch each shape on your paper and label it completely. So if we have to sketch each shape, I'm going to go ahead and do the front and back of that. So that's going to be 8 and 4. So that's 24 inches squared. And there's a second side and there's the back side. So don't forget the back side. So then there's 24 again. So those two places right there. So that is the front and back. Then I'm going to use pink for the side, and then there's another side here. So we're going to do the skinny one and another skinny one. So that's 8 and 2, 8 and 2 because it's 2 inches there. And so that's what we're going to be doing, 8 and 2. So that's going to be 16 and 16. So that's going to be it. So that is the side and side. And then let's use green. And we're going to say the base down here. So it's 4 wide and 2 long. And that's going to be the same thing here. So then we have base on top and base on bottom. And so that is going to be 4, 2, and then another one, 4, 2. So that's 8 inches squared, 8 inches squared. So write that down. Come back to this later. So you sketch each shape on your paper and label it completely. You can say that this is the height, and then this is the width. So again, height, width, this is the height and the length, and this is the width, and this is the length. All right? We're going to come back to that in a second. All right, so two cardboard sides of the box is called faces. Okay, we just said that. How much cardboard is needed to create all 6 sides, faces of the box? Work with your team to develop a calculating this method. So if you realize before, we had the front and the back. So here, the front and the back. So there's 2 faces on the front and the back. And then we also have 2 faces on the side and side. So we have 2 faces on the side and side. And then we had another 2 faces on the bottom and the top. So what was our face in the front and back? Well, it was the height and the length. And then on the side, we had the height and the width. And then on the base, so this is the front and back. This is the side and side, because there's 2. There's 2. And then for the base, top and bottom. That's why there's 2 here. We're going to do the length and the width. Now, to make this even easier, one thing you could do is you could multiply all of this later. So this is one way to figure out your surface area, but I can also distribute out and make this 2 parentheses HL plus HW plus length and width. So then I can just solve this, add them all together, and then multiply it by 2 once you're all finished. And we'll probably get some examples coming up soon. All right. So that is my method. The number of square units it takes to cover an outside the box, like the amount of cardboard, is called surface area. So the amount to cover the front, back, side, top, and bottom is called surface area, short for SA. All right, surface area. The volume. Okay, so how many cubes does it make to make this model cereal box? How many cubic inches of cereal will this hold? So cubic inches of cereal will the box hold? Okay, so now that is more so the volume of everything. So volume is the shape, the measure it will hold. All right, and in order to get volume, you do length times height times width. So in this case, it would be 4 times 2 times 8, which is 8 times 8, which is going to be 64 inches cubed. Cubed because there's 1, 2, 3 lengths here. And so that's why volume is cubed. Surface area is square because it's just covering a face, not holding anything inside that is bigger, 3-dimensional in a sense. All right, so let's go ahead and do that. I want to go straight into this right here. We're going to do some practice, 9:53. Let me check the time real quick. 10 minutes. All right, we're going to do a couple problems here. So if you look here, let's pretend each one is worth 1. So like, for example, that's 1, 1. So that's a height of 2. And then the width, so from left to right, there's 1, 2, 3. So it's probably better if I do it on top. 1, 2, 3 is going to be my width. And then my length is different. All right. So my length here is 1. But then I also have another length here. So this is separate. So let's just measure this right here. And we're not going to measure this. We're not going to measure this out thing. So if I had an above angle, it would be looking like this. So this is the above angle. All right. And we know that this is going to be 1, 2, right? This is a bad drawing. But it's for the above angle. It's like a Tetris block. We're only going to measure this part right here. That's what I'm focusing on. So this green area, and the stuff behind it. That is going to be 1. This is 3. Obviously, this is still 1, but the height is 2. Height is 2. So how do we measure the surface area of this? Well, we know we have 2 times length times height, length times width, and height times width. So we know our height is 2 and our length is 3. So we're going to say that the length is 3. The width is 1. So this is the width. So it's going to be 3 times 2 plus 3 times 1 plus height is 2 times 1. So that's 6 plus 3 plus 2. And that's 6, 7, 8, 9, 10, 11. So that's 2. So that's going to be 22. But that's only for this surface area. Now, that has to include this right here, that outside face, because this part is being blocked. So we're keeping this outside face covered. All right. So that is everything there. So now all we have to do is figure out how to cover. We're finding out the top of this, the bottom of this, the sides, and then the other side of that, since everything else is already taken care of. So we have that is 22 in green. So we're going to use the rest in red. So we know that this top is going to be 1 and 1. So that is 1 on top. And then we have to do the bottom plus 1. All right, so the 1 on top is 1. The 1 on bottom is 1. So that's our bases. Both bases. 1 on top, 1 on bottom. So that's 2 bases. And then we're going to add the sides. And so our height and our width is 1. Our width is 1. So we have height is 2 times 1. So that's 2. So height is 2. So 2 times 1 here. And then we got to do the other side, which is another 2. So that is going to be 4 and 2. That should be 6. So that means we should add 6 to this. So this should be 28 inches squared. All right, let's check the answer key. Hopefully this is what it is. Let me go ahead and duplicate and check the answers. Oh, it's saying there's error. 28 square units. We got it correct. All right. Now we have to do volume. All right, so that's a little bit trickier, but it's still the same concept of length, width, and height. So again, just to recap, we did the surface area of this, but since this face was showing and the backside of behind this, so like right in between there, that wasn't showing, we just took the surface area of the front. And then, so since that was left, we just had to go around the front. So we just had to go around the front there. So that's what's in red here. All right. So let's do volume. Volume of that. So again, if I look on top, what I want to do is I want to take the volume of inside here, and then I'll do the volume inside here. So first volume, we know it's 3. We know this is 1, and we know the height is 2. So we do 3 times 2 times 1, and that is the volume of this area here. So that's 6 inches cubed. And now we have to do the volume of this section here. And so we know that it's 1 wide, 1 length, and 2 in height. So then we do 2 times 1 times 1, which should be 2 inches cubed. And then we add that. So 6 plus 2 inches cubed, which would be 8 inches cubed. Is that correct? 8 cubic inches. Perfect. So that's it. Volume is a lot easier, obviously. Surface area is really tough, so we want to make sure that we get more practice in. But that's going to be it. Hopefully this makes a little sense. I'll give you some homework. Let me know if you have any questions on office hours, and I will talk to you all soon. Have a great day.